Hey guys, welcome to Unit 4, Chapter 3, Section 2, Day 2. Lots of fun stuff going on here. So you're going to need the notes that you have from the other day. We're going to continue on. We're going to fill in a couple of things that I left for you to do, and we're going to move on, and we're going to do Sections 2 and 3, where you have zeros of a polynomial multiplicity and also finding the zeros and their multiplicity and describe the graph. All right, so, but before we do that, I want to just make sure that you have number 10 and number 11 correct that I left for you. Hopefully you realize that if you're just looking at end behavior, and this was really easy, that with number 10, hopefully you realize that the highest degree was 3, so you had negative 6x cubed. So you put in 1 for that, so you get negative 6 times 1 cubed. Well, 1 cubed is 1 times negative 6 gives you negative 6, so that as x approaches infinity, I'm losing it. All right. As x approaches positive infinity, f of x approaches negative infinity. And then, again, the same thing, but you're going to put negative 1 in. So you got negative 1 cubed. Negative 1 times negative 1 times negative 1 is negative 1. Which gives you positive 6. So that means as x approaches negative infinity, f of x is going to approach positive infinity. So to continue on, we end up with our description. That means that as we go to the right, which is positive infinity, it falls to the right. And if we go to the left, which is negative infinity, it rises to the left. Okay? It's just that simple, guys. Just plug in 1, plug in negative 1. Just make sure that you have the highest value of the x. And if you have that, then all is good. So just for number 11, your highest value of x is negative 7/10 x to the 9th. And if you plug that in, if you plug in your positive 1, you end up with negative 7/10. When you plug in positive 1, and you end up with positive 7/10 when you plug in negative 1. So that means as x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches positive infinity. So again, it falls to the right and it rises to the left. Hopefully you'll practice that. I thought that that's a rather easy way to get started with this particular part of the unit. All right. So let's move on to the new stuff. I'm going to let you read that little box, okay? Read it to yourself, and it's going to sound really confusing, but it really is not that hard, okay? So let's go down. I'm going to go straight into the example, all right? And the example is this: f of x equals x plus 3 squared times 1 minus x cubed times x plus 2. Now you have 3 zeros here. Your 3 zeros are going to be negative 3, positive 1, and negative 2. And guys, when I say zeros, it's just what makes this equal to 0, what makes the second one equal to 0, what makes the third one equal to 0. All right, so that's why it says in the example, that's why it says negative 3, because that's one of your zeros. Now it has a multiplicity of what? Guys, this is your multiplicity right here, whatever the degree is of it, okay? So this has a multiplicity of 2. So guys, what does the 1 have a multiplicity of? Well, what's the degree? Well, you just look at the degree, it says, oh, it's 3. So 1 has a multiplicity. So in other words, whatever power it's raised to, that's the multiplicity. Well, what about x plus 2? Well, that gives you a 0 of negative 2, and that's a multiplicity of 1. Because if there's nothing up here, you can assume it's just a 1. That's how easy multiplicity is. Now, let's look at what a graph of this might look like. Okay? Well, before we do that, at negative 3, we have an even number, a multiplicity, right? If it's an even multiplicity, then it touches or it bounces on the graph. So an even number touches, an odd number cuts through. So 3 and 1 cuts through the graph. Cuts through. The graph. Okay? So let's see what this graph looks like. All right, so you have a graph already on your paper. So what you're going to need to do is you're going to need to put a couple of points on it. So you're going to need a point here at 1, because that's one of the zeros. And you're going to need a point at negative 2 and negative 3, because those are also zeros. Now, according to this, what does the function do? Well, at negative 3, it touches, it bounces, okay? Now, one of the things, what do we need to realize? What's the highest degree here? The highest degree is odd, right? If I have a highest degree of odd, that means it's coming from the bottom. Trust me. So we've got this, so it's coming up from the bottom, and then it bounces off, and then it comes back up somewhere, and now at negative 2, what does it do? Okay, here's negative 2. It has a multiplicity of 1, so it cuts through. And then it goes all the way over and comes back through 1 and cuts through again. Okay? It's that easy, guys. That's a sketch of that particular function. And this is what it looks like. Why does it bounce at negative 3? Because it has a multiplicity of 2, which is an even number. Why does it cut through at negative 2 and negative 1? Because it has a multiplicity of, this one has a multiplicity of 3, which is an odd number, which means it goes through. This one has a multiplicity of 1, which is also an odd number, which means it goes through. Okay, hopefully that makes sense. If not, well, this isn't the last time you're going to see all this. Okay, so let's do a couple problems here. Let's do number 12 first off. Now, number 12, we're giving you zeros, and we're telling you what the final degree of the problem is. Okay? So, we have zeros of 3, 6, and negative 9, and I want you to find the function. Well, that's pretty straightforward. F of x equals x minus 3. Why do I have minus 3? Because if this is a 0, if I solve this, what would make this equal to 0? It would be 3. And then I have x minus 6, and I have x plus 9. Now, all of these are degree 1. Now, what's 1 plus 1 plus 1? Well, 1 plus 1 plus 1 equals 3, so the degree of this polynomial is 3. Okay? Hopefully that makes sense to you guys. Let's look at number 13, and it might be a little bit easier for you. You have zeros of negative 5 and 0, And you also have a 0 of 4, but that is a multiplicity of 3. Okay, so again, just remember when you're writing the formula, the function, you've got to take the opposite sign. So this becomes x plus 5, and that's to the first power. You don't have to write the 1, but it can be. X plus 0, x minus 0, that's just plain old x. And then we have 4, so that's x minus 4. And it's a multiplicity of 3, so I have 3. Well, it's 1 plus 1 plus 3. That is equal to 5. And what does it say the degree of this problem is? 5. There you go. Okay. Number 14. You have 14 and 15 I'm going to leave for you because it's pretty straightforward. You do. Okay. So let's go down to number 16. What you need to do is I'm going to give you a function for number 16 and number 17, and you're going to have to write down but it's going to be in a graph form, okay? So for number 16, I'll do that with you, and then for number 17, I'm going to show you what the graph looks like, and then you're going to go from there. All right, so for number 16, you want to make this graph. You already have the basics, but I'm going to do 1, 2, 3 over here, 1, 2, 3 over here. So I'm going to have a point at negative 2. I'm going to have a point at positive 1. I'm going to have a point at 3. And this is what the graph looks like. Now the nice thing with this, there's a basic one. There's like an infinite number of possibilities here, okay? But we're going to go with just basic stuff. So what are my 3 zeros? My zeros are at negative 2, 1, and 3. So what does that look like? So that becomes x plus 2. Now I can make this to any odd power that I want to. Why does it have to be an odd power? Because it cuts through. So I'm just going to leave it as 1 because that's as easy as it gets. I could make it 3, I could make it 5, I could make it 11, I could make it 111 as long as it's an odd number. Then I can have x minus 1 to any odd power. I'm going to make that one 5. Just for fun, okay? If I don't tell you what degree the polynomial has to be, you have infinite possibilities. This number could be 3, it could be 7, it could be 1, it could be any odd number. And again, for the last one, I have x minus 3, and again, choose any odd number you want. Do not choose negative numbers, people. That makes things a whole bunch worse. Just positive, odd, or even numbers. So I'm just going to make this a 1 also. So what would the degree of this polynomial be? Well, if you add these up, this would be a degree 7. But since I didn't tell you what degree it had to be, it could be anything. But it's going to be an odd number because an odd plus an odd plus an odd is always odd. All right, so number 17, I'm going to give you the graph, and you come up on your own in your own notes with a reasonable function for it. So we're going to do 2 on the right hand side, we're going to do 3 on the left hand side. We've got my y here, this is x. So I've got a point at 3, negative 3, sorry, and a point at positive 1. And this is what this function does. So you tell me what happens there, okay? And when I do my next video, when I do the next video, I'll give you one possible answer out of the infinite number of answers there could be. All right, now section 3. It says find the zeros in a multiplicity and describe the graph. You need to factor. All right, I'm going to do numbers 18, 20, 23, and that's it. And we'll leave 19, 21, 22, and 24 for you guys, because this is not that bit difficult either. So for number 18, it says f of x, and of course you have these in your notes, hopefully. X squared minus 8x minus 20. And it says you need to factor, and you're finding a 0, so 0 equals x squared minus 8x minus 20. Yes, in order to do well in this class, you need to know how to factor. That's why when when you were freshmen, we tried to teach you we took a long time to teach you how to factor, because it comes up again and again and again and again. All right, so we have x equals 10, x equals negative 2. So those are the two zeros. How many times does the 10 appear? Well, this is 10 to the first, this is x plus 2 to the first, so I have a multiplicity of 1, and I have a multiplicity of 1. So that's part of the answer. And to describe the graph, cross, cross. You don't have to show me the graph, just describe it. So it's going to cross at to positive 10, it's going to cross at negative 2. That's it. That's all you have to do right now, guys. Let's do a couple more problems, show you what we're talking about. A little bit harder one here. So basically, if you can factor, this stuff is like really easy, but guess what? If you struggle with factoring, you're going to struggle with this. Okay? So we've got f of x equals negative 2x to the fourth plus 2x squared. So we got 0 equals negative 2x to the fourth plus 2x squared. So I've got negative 2x squared times x squared minus 1. Okay, so be careful here. Negative 2x squared equals 0. X squared equals 0. X equals plus or minus 0. So this is a multiplicity of 2. Okay, so it's going to bounce at 0. Then we have x squared minus 1. Well, that's x minus 1 times x plus 1. So I've got x equals 1, and I've got x equals negative 1. Okay, so I've got a multiplicity of 1 and a multiplicity of 1, because they are different numbers. 1 and negative 1 are not the same number, so that means it crosses here and it crosses here. Okay, you can imagine what the next section is going to be. It's going to be graphing these things. Putting it all together to graph. It's actually really straightforward. If you can do do the endpoints, and then you can do this, it's easy peasy, lemon squeezy. Okay. Now number 23 is a funny problem. Okay, so that's why I'm going to do that one for you. We have f of x equals negative x to the fourth plus 8x squared plus 9. And we'll set that equal to 0. And I'm going to pull out that negative 1 because I don't like it. Okay. That negative 1 means nothing other than, well, actually it doesn't really mean anything. So as far as this goes, so we're going to leave that, we're going to ignore that. So we do have x, but this, I noticed that a lot of you have problems with factoring these. Guys, this is, if you have a step down of 4 to 2 to 0, that's very factorable. What gives you x to the fourth? That's x squared times x squared, right? Now, what gives you 9? It's either 9 and 1 or 3 and 3. Well, I need 8, so 9 and 1 is the ones that are going to work. Okay? So then I have minus 9 and plus 1. Okay. Well, the nice thing about this one, we get x squared equals -1. Now, hopefully you realize that, oh, wait a minute, that's not going to make any sense. That's going to be an imaginary number. What's nice about this is that since it's an imaginary number, don't worry about this. Basically, it's saying it has two imaginary roots. You could tell me what they are, but you don't have to worry about those. But this, the x squared minus 9, well, that is you know, a difference of perfect squares. That's x minus 3 times x plus 3. So that gives me a 0 of 3 and -3. I have a multiplicity of 1, and I have a multiplicity of 1. So that means that each cross. Okay. And that's it, guys. I'm going to leave the others for you to practice on. Please be practicing with these. You know, I'm not asked, you know, it's not homework, but it is good practice for you to do. And like I said, I will be showing you next time I do a video, just like I started out this one, exactly what those answers should be. All right, guys, have a great day. Behave yourselves. Those of you that haven't been watching the videos or doing the work, pick it up. You seniors, this is one of the last things you have to do. All right, guys, bye.